Okay, property 4. R is not resistant, and R is, this is a typo, okay? R is dimensionless. That means R has no units. Okay? Now let's see why R is not resistant. Look at the formula here. R depends on average and depends on standard deviation. And we know both average and what? Standard deviation are not resistant to what? To outliers, okay? So that means R cannot be resistant. It's a very simple idea, okay? Now, second one, R has no units, okay? R is dimensionless. Say we want to study the relationship between X and Y, okay? Say X is what? X is a weight. Y is a height, okay? And the unit used, say I use centimeter, okay? So look at the formula here. Look at this formula here. The data, X, unit use, centimeter. If X is, the unit for X is centimeter, what's the unit for average X? It's still centimeter. And what's the unit used for standard deviation X? Average distance to the center. Unit use still centimeter, okay? How about variance of X? Remember, variance of X is what? Standard deviation X squared. So in this case, variance of X, unit use is centimeter squared, okay? Now, look at here, this formula. X minus average X. So X minus average X. Distance to the center, what's the unit use? The centimeter still, okay? And it's divided by standard deviation X. Average distance to the center, unit use still centimeter. And centimeter cancel with centimeter, okay? That is just what? A number, no units. So you know this is z-score, okay? The standard unit. Z-score, we standardize X, we get z-score. And z-score just a number. Just a number. Z-score has no units, okay? So for the same reason, this is just a number. And this is also just a number. Number times number is a number. Sum a whole bunch product terms of numbers, still a number. Divided by sample size minus 1, still a number. So R is just a number. R has no units, okay? Property 5, ecological correlation are based on rates or averages. They are often used in political science and sociology, and then tend to what? Overstate the strength of an association. So watch out, okay? Look at the data set, okay? Data are collected from 3 provinces, okay? And they are British Columbia, Alberta, and Quebec, okay? So the added categorical variable is province. So you see in the picture, there are 3 groups, okay? when we put when we add a categorical variable in a scatter plot like this, we can either use different color. For example, in my notes, I think this dot is in red, okay? And the triangle is in what? In blue. And the check is in black, okay? When you add a categorical variable in the scatter plot, you can either use different symbol or use different color, okay? Now let's count the data set. The data collected from what? From British Columbia. 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So MB, the data size from BC is 9, okay? How about Alberta? 13, okay? And Quebec is 6. And we want to study relationship between education level and income, okay? Both are quantitative variable. And look at here. If we use the computer software and compute R, this is R1. And you can see this is football shape, okay? It's a linear association. So R1 is positive, okay? Now, if somebody change the way how we want calculate R a little bit, instead of use each single point, okay? He or she just use what? 3 points. And what's this point? This top point is the coordinate is called X bar B and Y bar B. Okay, let's define what's X bar B, Y bar B. Okay, X1B plus X2B plus all the way up to X9B divided by NB. This is called XB bar. This is average school years, okay? Or this is used to measure education level. Average school years. For sample collected from BC. Okay? And similarly, what's YB bar? Okay? XB bar is X1B. The first person collected from BC, his or her school years, plus the second person all the way up to the ninth person, and divided by the sample size or sample collected from BC. This gives what? Average school year for sample collected from BC. And what's YB bar? Is Y1B plus all the way up to Y9B corrected by MB. So this is average income of sample data collected from BC, okay? From BC. So this is called the point or average. That is what? The center of those data collected from BC. Just summarize all information by a single point. Use the single point to what? Represent the whole BC, okay? Now, similarly defined, Similarly, we define XA bar, YA bar, XQ bar, and YQ bar, okay? And these coordinates, X A bar, and what? YA bar. And this point here, XQ bar and YQ bar, okay? Here I have how many points? 28 sample points. I use all of them, compute R1. And here I have only 3 points, okay? I get the R2. And the question is, which one is bigger? R1 absolute value or R2 absolute value? Remember, when we put absolute value, we are comparing their what? Strengths. How strong is the linear association? Which one is stronger? This is stronger or this is stronger? Can you tell from the picture? I give you a hint, okay? Suppose I cover this point up. Okay? If I cover this point up, I have only 2 points. These 2 points, you know, 2 points determine a line. Am I correct? So what is the correlation coefficient if I only use 2 provinces? 2 points determine a line, and the line has a positive slope. As you can see, if this is the case, R2 is what? R2 is positive 1. Am I correct? But we have the third point here. Okay? From this example, tell us one thing. If I use less point, I definitely going to see what? More stronger what? Linear trend. So this is what? R2, the strength you see in R2, definitely bigger than R1. Okay? But tell me, R1 is more trustworthy or R2? Which one is more trustworthy? Well, of course, R1, right? This is more trustworthy. Because this one uses detailed information. Why R2 is bigger? Because R2 is what? This R2 is ecological correlation. It tends to what? Overstate the strength. Okay? A lot of sociologists, okay, they like to use what? Ecological correlation. But that way they tend to overstate what? The strengths. Okay? So be careful. R1 is more trustworthy. Okay?